Alright, today's video we are talking about experiments, especially experimental diagrams. As you can see, this is entry 28. Yours may be different, just depends on when we hit it during the year. The standard we are talking about is MM3D3, which means we are talking about this with Math 3, specifically the data analysis standard. You may want to take a minute, pause this, and then write down the definitions here. Confounding variable is confounding generally means confusing. So this is one of the definitions we generally do not talk about a lot. It is something that influences two factors and is the reason there appears to be a relationship between the two factors, but there generally isn't one. It's something that just happens to be related, but it doesn't make sense. Explanatory variable. This right here is the independent variable for the situation. This is the variable that is being altered between the two groups in the study and whose effect is being studied. The explanatory variable is where the treatments come from, and we will get to those here in just a minute. Generally, treatments are multiple different recipes of the same thing, or different types of shirts, different types of the same type of thing of clothing, as long as it's a different something. The response variable. This is the outcome being analyzed in the study. It's the outcome we want, which means it makes it the dependent variable of the study. Next up, this is the study diagram. You will want to have this. Now, your experimental units, remember that is your amount of people that we have. The treatments, you can have as many lines of this as you need. It depends on how many kinds of things we have going on. In this case, there are 4, which means there are 4 different things being tested at the same time. And as you can see here with these lines, that it distributes the experimental units or the people equally between the treatments. And then on the end, we have the response, the outcome that we are looking for on the end. All right, example 1, take a minute and read. Okay, first off, we have an energy drink manufacturer. It doesn't tell us which one, just that it's a manufacturer. So, first off, they want us to identify the experimental units. That's our people. Only one I have to see here with people is 90. So, our experimental units are 90 people. Alright, our explanatory variable. Remember, that's the one that has the multiple treatments. I see 3 recipes here, but we want to know 3 recipes of what? And of course, we're talking about energy drinks, so energy drinks is our explanatory variable. Now, determine the treatment. These are the things that have the multiple things going on at once. So we have recipes A, B, and C are the treatments because there's multiple of them. The response variable, that's what we want to see at the end. So we want the longest energy boost. So that's what we want here for the response. So the longest energy boost. Now, it wants us to draw the diagrams. We're going to use that information that we just came up with over here, and we're going to plug it in over here. So, our experimental units, that's our 90 people. Now, we said with each arrow, we need to divide it up. We've got 3 hours going on, so we need to divide 90 by 3. And when you think 90 divided by 3 is 30, so that means there should be a 30 with the top row, 30 going with the middle, and 30 going with the bottom. Now at this point we have our 3 treatments, and that's our recipes, so we can just use A, B, and C to make our work easier. We have A, B, and C. Now our response variable, that is our long energy boost. And there we go. Next example, take a minute, pause and read. Okay, experimental units, we're talking people here. The only number I see here with people is 100 students. Alright, the explanatory variable, the thing we have multiple versions of. So we're taking an exam, whether or not to use notes or not to use notes. So our explanatory variable here is the test. The treatment, these are the 2 different versions we've got. We've got notes and no notes. Now the response, or the outcome we want to see, is which one's going to have the higher average test score. So that's our response. higher average test score. And here's our diagram we need to fill in. So remember, experimental units, we had 100. Now, since we've got 2 treatments, we need to divide 100 by 2. So each one should get 50. Now, if you think we've got 2 treatments, we've got notes and no notes. Don't know about you, I probably want to be in the notes section. And then our response variable, that outcome that we want, so the higher average test score. And there we go.